hope you people have revised whatever I've done in the previous classes. Today I will be teaching you the concept of electric scalar potential. The electric scalar potential. Electric scalar potential. Very important topic. Let me consider 2 points. Let me consider 2 points B and A. Let us consider 2 points B and A. These 2 points are at a distance RB. This distance is RB. From the origin, this is the origin, from the origin O. Point B is at a distance RA. Point A is at a distance RA. Is at a distance RA from the origin. RA from the origin. I repeat, we have taken 2 points A and B. Point B is at a distance RB from the origin O, while point A is at a distance RA from the origin. Let these 2 points be joined by some random path. The random path connecting points A and B. Let us consider an elemental length dl. This is elemental length dl of this random path. I repeat, we have taken 2 points B and A, which have got distances RB and RA respectively from the origin. Let the points B and A be connected by a random curve. We have taken an elemental length dl of this curve. Midpoint of dl is at a distance r from the origin. Midpoint of dl is at a distance r from the origin. I am going to write whatever I have said. Let us consider 2 points. Let us consider 2 points A and B having the distances RA and RB from the origin O. Let these 2 points be connected by a random path as shown in the figure. Now let us calculate what is the work done in displacing a charge of q coulombs by distance dl. So I am going to say now, let a charge of plus q coulombs be moved from B to A. Let a charge of plus q coulombs be moved from B to A. Also let a charge of plus q coulombs be moved from B to A. Work done in moving the charge by an elemental distance dl is. What is work done? dw equals what? Minus f dot dl. The negative sign indicates that the work is done. By an external agent and not by the force. What is F? F is Q into E. So this becomes what? Minus Q into E dot dl. There are two units for electric field intensity. They are volts per meter and joules per coulomb and newtons per coulomb. So unit of, if you take unit of E as newtons per coulomb and unit of Q is obviously coulombs. So coulombs into newtons per coulomb gives you newtons, which is nothing but the force F. This I will call equation 1. I have just now told the significance of this negative sign. The negative sign indicates that the work is done by the force F. The work is done by an external agent and not by the force F. I am going to say now, the negative sign indicates that the work is done by an external agent and not by the force. If you take a plus sign, it means work is done by the force and not by the external agent. Now this is the work done in displacing charge q by a small distance dl. So what is the work done? What is the work done when charge of q coulombs is moved from B to A is the next issue. So I am going to say, hence the work done in moving the charge of plus q coulombs from point B to point A is WAB is equal to minus integral E dot dl from point B to point A. Unit of WAB is joules into Q. Q into E is nothing but vector F. This is the work done in moving a charge of plus Q coulombs from point B to point A. This implies, what is WAB? WAB divided by Q is called potential difference between the points A and B is equal to minus integration from B to A on E dot dl. This is a line integral B to A vector E dot dl. Unit of this is joules per coulomb or volts per or volts. Joules per coulomb or volts, where VAB is the potential difference. VAB is the potential difference between the points A and B. Between the points A and B. In fact, VAB is the work done per charge, work done per coulomb. The work done in moving the charge of plus Q coulombs from point B to point A and back from A to B must be 0. That means contour integral C vector E dot dl is equal to 0. What I mean is, take a charge of Q coulombs, move it from B to A, then back from A to B. Total work done will be 0. That means electric field is conservative in nature. Work done in moving the charge from B to A and then from A to B is 0. Work done in moving the charge from B to A and then from A to B is 0. That is contour integral C vector E dot dl is equal to 0. Equation 2 means static electric field is conservative in nature. Equation 2 means electric field intensity is conservative in nature, and this is true only for static electric fields, and it is not true for time varying electric fields. Very, very important. Equation 2 means electric field intensity is conservative in nature. This conservative property is true only for static electric fields, and not true for time varying electric fields. Very, very important. Time varying electric fields. Time varying electric field means when charge distribution changes with respect to time, the electric field intensity produced by such a charge distribution is called time varying electric field. That means when Q is a function of time, vector E will be a function of time. Then this equation will be not valid. When Q is not a function of time, then this equation is true. That means this equation is true only for static electric fields. What is the significance of this equation? That also I will tell you now. Let us consider 2 points B and A as we have taken earlier. This is contour C1. This is contour C. This is path C1. This is path C2. These two paths put together define contour C. Contour C is what? C1 plus C2. Right? Equation 2 when applied to figure 2 gives, this is figure number 2. This is figure number 1. Figure 2 gives integration from B to A vector E dot dl. This is along contour, along path C1 plus integration of vector E dot dl from A to B along path C2 is equal to 0. If you interchange the limits of integration, you get integration from B to A along path C1 vector E dot dl minus, when you change the limits of integration you get a minus sign, B to A vector E dot dl is equal to 0. This is along path C2. This in turn implies, take this integral to the right side. Integration from B to A along path C1 vector E dot dl is equal to integration from B to A integral E dot dl, integration of E dot dl from B to A along path C2. What this equation means? This equation means work done in moving a positive charge, unit positive charge you can say, from B to A along two different paths, C1 and C2 will give identical result. So the shape of the curve connecting B and A is not important for us. This is what this means. work done in moving a positive unit charge from B to A is same as moving the same charge along a different contour C2. That's what it means. Okay. This is the significance of this equation. What I have done is this contour integral, contour means closed integral, I split into two path integrals. I changed the limits of integration. Because of that I have got a minus sign here. Then I moved this integral to right side. So what this integral means, work done by a unit positive charge along path C1 must be equal to work done along path C2. That is the significance. Right? The above equation means the work done by a test charge along two different paths remain identical. The above equation means the work done by a test charge along two different paths remain identical. Paths remains identical. Now, next what I will do is, I want to introduce the concept of absolute potential at a given point. I'll assume we have kept a charge of q coulombs at the origin. This is the electric field intensity produced by a charge kept at the origin. Let a charge of q coulombs be kept at the origin. Then it produces an electric field intensity vector E as shown in figure number 1. As shown in figure number 1. Then what is vector E? Vector E is equal to Q divided by 4 pi epsilon R square into ER cap. So many volts per meter. Hence what is VAB? VAB is equal to minus integration from B to A vector E dot dl is equal to integration. What is vector E? Q divided by 4 pi epsilon R square into AR cap dot. Vector dl, this is vector dl. Vector dl has a magnitude equal to dr and direction is equal to AR cap. This is vector dl. Magnitude of vector dl is dr and the direction is given by AR cap. The unit vector associated with vector dl is AR cap. AR cap dot AR cap is 1. What is the distance of point B from the origin? It is RB. What is the distance of point A from the origin? It is RA. So this implies VAB is equal to integrate this. If you integrate this, AR cap dot AR cap is 1 minus integral RB to RA Q divided by 4 pi epsilon R square dr. 1 by R square, if you integrate, you get minus 1 by R. So you get what? Q divided by 4 pi epsilon into R, limits from RB to RA. So if you put limits, you get Q divided by 4 pi epsilon into RA minus Q divided by 4 pi epsilon into RB. The first term gives you potential at point A, absolute potential at point A. The second term gives you absolute potential at point B. That means VAB is VA minus VB. Where VA and VB are absolute potentials of the points A and B. I call this as equation 3. I hope I have not used equation 3 before. Now I want to define what is absolute potential at a given point. In equation 3, we let RA is equal to R and RB equal to infinity. Then what happens? Then VAB equals V equals Q divided by 4 pi epsilon into R minus 0. When you put RB equal to infinity, this becomes 0. This gives Q divided by 4 pi epsilon into R volts. So V is the absolute potential at point A due to a point charge of Q coulombs kept at the origin. VAB I called it as V, where V is the absolute potential at point A. Correct? What do you mean by RB equal to infinity? When you put RB equal to infinity, VB becomes 0. Therefore, the infinity reference will mean a surface or a point where the potential is 0. In other words, RB equal to infinity means ground. RB equal to infinity means ground. Since RB equals infinity makes VB equal to 0, physically infinity reference means the point where the potential is 0. For example, ground or earth. Equation 4 is used for defining absolute potential at a point. It is defined as, okay, I'll give the definition. The absolute potential at a point is defined as the work done by a unit positive charge moved from infinity reference. Infinity reference means ground. Infinity reference to the point under consideration. What I said, the absolute potential at a point is defined as the work done by unit positive charge moved from infinity reference to the point under consideration. Very, very important. Okay, this is the definition of absolute potential. So in today's class I have told what is an electric scalar potential. Then I have told you electric scalar potential means if you look at the expression for V, it doesn't have any unit vector in it, therefore it's a scalar. Therefore, potential is scalar, whereas electric field intensity is a vector. Only a problem on electric scalar potential. The problem statement I will read out. An electric field intensity is given in spherical coordinates at P 5, 30 degrees, 60 degrees as vector E equals 20 times AR cap minus 30 times A theta cap plus 60 times A phi cap. Find the incremental work done in moving a 100 microcoulomb charge to a distance of 0.08 micrometers in the following directions: AR cap, A theta cap, A phi cap and vector E. So I am going to write down now given data, given point P is what? R is equal to 5, theta is equal to 30 degrees, phi is equal to minus 60 degrees. Vector E is equal to 20 AR cap minus 30 A theta cap plus 60 A phi cap volts per meter. What is the charge? Q is equal to 100 microcoulombs. What is the elemental distance? Delta L. Delta L is equal to 0.08 micrometers. The problem I will start now. Problem will start. Solution we have started. So I will do first part A. Before part A, I will do some calculations. What is elemental work? What is incremental work done? Delta W is equal to minus Q times dot product of vector E and vector dl. This is the elemental work done. What is the unit? Unit is joules. Now I will do part A. We know that I have written here. We know that incremental work done is equal to minus Q times, correct, dot product of vector E and vector dl. In part A, what is vector dl for part A? It is in direction AR cap. So what is it is magnitude of vector dl is magnitude of vector delta L is delta L. And what's the direction? Direction is AR cap, because he has asked what is the work done in the direction AR cap. Therefore, unit vector associated with this elemental length vector is taken as AR cap. So therefore, delta W is equal to minus Q. Q is what? Q is 100 microcoulombs, 100 into 10 to the power minus 6. What is vector E? What is vector E? Vector E is 20 times AR cap minus 30 times A theta cap plus 60 times A phi cap dot. What is vector? What is vector delta L? Nothing but delta L into AR cap. What is this delta L? Delta L is 0.08 micrometers. This delta L is 0.08 micrometers. That means 0.08 into 10 to the power minus 6 meters. So if you take dot product, AR cap dot AR cap is 1. A theta cap dot AR cap is 0. A phi cap dot AR cap is 0. Therefore, this becomes delta W is equal to minus 100 into 10 to the power minus 6 into 20 into 0.08 into 10 to the power minus 6. So this becomes minus 160 picojoules. This is the answer. So this is the work done in moving a charge of 100 microcoulombs by a small distance 0.08 micrometers in the presence of this electric field. In which direction? AR cap direction. This is the answer. Next I will go to part B. I will go to part B. For part B, what is elemental length of the vector? Vector delta L is equal to delta L into A theta cap. Why A theta cap? Because the direction specified is A theta cap. So what is delta W now? Q is what? 100 into 10 to the power minus 6. What is vector E? 20 AR cap minus 30 a theta cap plus 60 a phi cap dot vector delta L is what? Delta L into a theta cap. AR cap dot a theta cap is 0. A theta cap dot a theta cap is 1. A phi cap dot a theta cap is 0. Therefore, this becomes minus 100 into 10 to the power minus 6 into minus 30 into delta L. This is nothing but minus 100 into 10 to the power minus 6 into minus 30. Delta L is 0.08 into 10 to the power minus 6. So this works out to be 240 picojoules. Please check the answers. Mostly they are correct. However, if there are mistakes, please point out. 240 picojoules. Next, I will go to part C. For part C, what is vector delta L? Nothing but magnitude is delta L. Direction is given by a phi cap. So delta W is equal to minus Q is 100 into 10 to the power minus 6. What is vector E? 20 into AR cap minus 30 into a theta cap plus 60 into a phi cap dot delta L into a phi cap. So this becomes now minus 100 into 10 to the power minus 6 into 60 into delta L. A phi cap dot a phi cap is 1. A theta cap dot a phi cap is 0. AR cap dot a phi cap is 0. So what is this? Is nothing but minus 100 into 10 to the power minus 6 into 60 delta L 0.08 micrometers. So 0.08 into 10 to the power minus 6. So this works out to be minus 480 picojoules. Please check the veracity of this answer. Now last part. Last part is in which direction? In the direction of the electric field. In the direction of the electric field. Unit vector, the direction of the electric field is AE cap. For D, unit vector, here vector delta L is equal to delta L into AE cap. AE cap. So please note now what happens in this equation. Delta W, hence delta W is equal to minus Q. What is vector E? Vector E has got a magnitude equal to E. Direction is equal to AE cap dot. What is vector DL? Magnitude is DL. Direction is AE cap. AE cap. AE cap dot AE cap is 1. So you get what? Minus Q into E into delta L. What is E? E is nothing but the magnitude of the electric field intensity. So minus Q is 100 into 10 to the power minus 6. What is the magnitude of the vector E? Coefficient of AR cap square, which is 20 square. Coefficient of A theta cap squared plus coefficient of AY cap squared into delta L. Delta L is 0.08 into 10 to the power minus 6. This works out to be minus 560 picojoules. This is a problem asked in the exam 2 or 3 times. So he has asked to find work done in different directions. This is how the problem has to be solved. We will go to the next problem. The statement is evaluate the integral a1 to a2 on vector f dot dl if vector f is equal to x square ax cap minus xyz az cap newtons. Given the points a1 1 2 3 and a2 5 0 4. And these lie on a straight line, which is the intersection of the planes. X is equal to 5 minus 2y and y is equal to 8 minus 2z. When these two planes intersect, you get a straight line. These 2 points lie on that straight line. So what is the work done? We have to calculate. So I will start the solution. See, whenever a problem is given, read the problem correctly once or twice, then come to the solution. This is vector f. So now, what are the points given? This is a vector given. What is fx? Fx is equal to x square, coefficient of ax cap. What is fy? Fy equal to 0. Why fy is 0? Because there is no unit vector ay cap. What is fz? What is fz? Fz is coefficient of az cap minus xyz. All these are in newtons. I list down the points. Points A1, points are A1, 1, 2, 3 and A2, 5, 0, 4. About the lines, we have been given the following. See, the line is produced by the intersection of these two planes. So about the line, I'll get the certain calculations done. X is equal to 5 minus 2y. This implies what is dx is equal to? Dx is equal to minus 2 times dy. Dx is equal to minus 2 times dy. Then given y is equal to 8 minus 2z. This implies 2z is equal to 8 minus y. This implies 2 dz is equal to minus dy. This in turn implies dz is equal to minus 0.5 dy. Okay. Now we will evaluate this integral. Before we evaluate this integral, I want fx, fz to be expressed in terms of y. What is x? X is equal to 5 minus 2y. So fx is equal to what? Fx is equal to x square. What is x? F5 minus 2y. So this is 5 minus 2y whole square. A minus b whole square. A square minus 2ab plus b square. So this is 25 minus 20y plus 4y square. What is fz? Fz is equal to minus xyz. What is x? X is what? X is 5 minus 2y. What is z? What is z from here? What is z? 2z is equal to 8 minus y. So what is z? 4 minus 0.5 y. Divide both sides by 2. 8 by 2 is 4. Y by 2 is 0.5. What I want is, I want fx, fz to be expressed in terms of y only. Therefore, I replaced x by 5 minus 2y. In this expression, x is replaced by 5 minus 2y and z is replaced by 4 minus 0.5y. Now that has to be expanded. If you expand this, the result that you are going to get is, we'll expand it. This implies fz is equal to y into minus y, 5 minus 2y into 4 minus 0.5y. Remove the brackets. So this is minus 5y plus 2y square. Minus 5y plus 2y square into 4 minus 0.5y. Remove the brackets now. Minus 5y into 4 is minus 20y. Minus into minus plus. This becomes 5 into 0.5 is 2.5. 2.5y square plus 8y square. 2 into 0.5 is minus 1 minus y cube. So this becomes now this becomes minus 20y plus 10.5y square minus y cube. Okay, this is the expression for fz. This is the expression for fz in terms of y. So I am going to list it here. So what is fz? Fz is equal to minus 20y plus 10.5y square minus y cube. Now we will proceed to evaluate this integral. Hence integral a1 to a2 vector f dot dl is equals integral a1 to a2 vector f has got only components fx and fz. Fx into ax cap plus fz into az cap dot. Vector dl is dx into ax cap plus dy into ay cap plus dz into az cap. So this becomes integration from between the points a1 and a2. Coefficients of ax cap you multiply, coefficients of az cap you multiply and add. That is the result of a dot product of these two vectors. So you get fx into dx plus fz dz. Now this becomes, I'll split this integral into two parts. Integration, what is fx in terms of y? It is 25 minus 20y plus 4y square. What is dx? Dx is minus 2 times dy, which I have done in the beginning only, or from here see x is equal to 5 minus 2y, therefore dx is equal to minus 2 dy. Now the quantity inside the integral is a pure function of y, therefore for a1 and a2 I have to write only y coordinates. What is y coordinate for point a1? It is 2. What is y coordinate for point a2? It is 0. This can be evaluated. Plus, I will take this integration. What is fz in terms of y? It is minus 20y plus 10.5 y square minus y cube. What is dz? Dz is nothing but minus 0.5 dy. This I have done in the beginning of the solution. Limits again from 2 to 0. So please don't think this integral is only for this term, it is for both the terms. Therefore, in order to make it clear, let me put a bracket. So now this integral, these two integrals have to be evaluated. Please note that what we have done is fx and fz, we have made pure functions of y. Therefore, in point a1 and a2, only y coordinate has to be used. If you integrate this and substitute, you will get the result 37.33 joules. Please do this as an exercise. Evaluate these two integrals, not difficult. Correct? What is integration of y square by 2? What is integration of y square, y cube by 3? Very easy. Simplify the integral, this should be the answer. Please check and report to me if there are any discrepancies. Thank you. Next, we'll go to a very simple problem asked in the examination. 2 point charges Q1 and Q2 are located at A1 0 0 0 and A2 1 0 0. Find the potential at P 1 2 3. So charge Q1 is located at the point A1 0 0 0. Q2 is located at the point A2 1 0 0. P is the point having the coordinates 1 2 3. Distance from A1 to P is R1. Distance from Q2 to P is R2. Potential at point P is Vp. Vp is what? V1 plus V2. V1 is the potential due to Q1. V2 is the potential due to Q2. So Vp is equal to V1 plus V2. What is V1? It is nothing but Q1 divided by 4 pi epsilon into R1. What is V2? V2 is what? Q2 divided by 4 pi epsilon into R2. R1 and R2 are calculated using distance formula. So Q1 divided by 4 pi epsilon. What is R1? Square root of 1 minus 0 whole square plus 2 minus 0 whole square plus 3 minus 0 whole square plus Q2 divided by 4 pi epsilon square root of 1 minus 1 whole square plus 2 minus 0 whole square plus 3 minus 0 whole square. This is the expression for Vp holds. We have applied the principle of superposition here. We have found the potential due to Q1 at point P, potential due to Q2 at point P, then we have added. Now, if you want, you can simplify this. This implies Vp is equal to Q1 divided by 4 pi epsilon into square root of, this is 1 plus 4 plus 9 plus Q2 divided by 4 pi epsilon into root of 2 square is 4 plus 9. So this becomes Q1 divided by 4 pi, this is 9 root 14, 4 pi root 14 into epsilon plus Q2 divided by 4 pi root 13 into epsilon. So many folds. So Q1 and Q2 values are not given, therefore I keep the generalized answer. Thank you.